Hello, everyone. Welcome back to another question. And in this question, we're going to be taking a look at equilibrium. And this is an MCQ question, as you probably already noticed. It's from the May 2017 batch, and it's an HL paper. So the question asks us, consider the equilibrium between N2O4 and NO2. And they have given us the enthalpy change of the forward reaction. It is positive 58. That means the forward reaction. So the forward reaction is positive 58. That is the enthalpy change. That means it's endothermic. And they've asked us which changes shift the position of equilibrium to the right. Now, there are really two ways to approach this. I'm going to tell you the very first method, and the first method is the easiest method. If you look at the three options they've given us of the three conditions which they say or which they have told us to decide which of these three conditions are going to change or shift the position of the equilibrium to the right, by looking at the very third, last option, they've told us adding a catalyst. And this is absolutely wrong. A catalyst does not have any effect on the position of the equilibrium. A catalyst actually increases the rate of reactions, both reactions, the forward and the reverse reactions, equally. So it has no effect on the position of the equilibrium. And they allow an equilibrium to be reached more quickly and do not have an effect on the position. So 3 is automatically wrong. And you can see that any option with 3 is immediately wrong. So B is wrong, C is wrong, and D is wrong because they all contain 3, which is also wrong. So your only option left is A, and this is also your correct option. So that was fairly simple. But if you do not want to do it like this, if you want to understand why or which of these affects the position of the equilibrium and which of these will shift it to the right, I'm also going to explain that. So let's take a look at the first one. So now we know that the answer is A, so I'm just going to set that aside. We reached this using method 1. I'm going to tell you method 2. So the second method, let's look at this logically. So I'm going to draw the, I'm going to write down the chemical equation over here. So gives us 2NO2, they're both gaseous. So the first one, increasing the temperature. So they have told us that the forward reaction is endothermic. So if the forward reaction is endothermic, the reverse reaction will be exothermic. So what I mean is the conversion of N2O4 to 2NO2 is endothermic, but the conversion of 2NO2 into N2O4 is exothermic. So anytime the forward reaction is endothermic, the reverse reaction will be the opposite. So it will be exothermic. But if we swap these two things, if we say that the forward reaction is exothermic, supposing, just imagine the forward reaction was exothermic, then the reverse reaction would become endothermic. Now, obviously, this is not true because as we can see from the equation, they have told us that the forward reaction is actually endothermic. So that would mean that the reverse reaction is exothermic. Now, how does this help us in any way? If we know that the forward reaction is exothermic, when we increase the temperature of the reaction, what the reaction, if we tend to increase the temperature of this specific reaction, right? It's happening in a closed chamber, and we suppose we increase the temperature. The equilibrium is going to do its best to maintain the current conditions instead of letting them change. So when you increase the temperature, it becomes hotter. And if you imagine yourself, if you are sitting in a room and you start to feel hot, what do? You turn on the AC, or you turn on the fan, or you open the window so that it becomes cooler. So in response to this increasing temperature, the reaction is going to try to become cooler, and therefore it's going to shift to the right. Why to the right? Because the forward reaction or the reaction towards the right is endothermic. And remember, endothermic is a cooling effect. So in response to the increase in temperature, which is exothermic, it's going to balance it out by moving to the right so that it produces an endothermic reaction. And that's why increasing the temperature does indeed shift the position of the equilibrium to the right. So 1 is correct. Let's take a look at the second one, decreasing the pressure. And just before we move on to decreasing the pressure, since we know that increasing the pressure is correct, any option without increasing the pressure should be wrong. So we can eliminate C. Now let's move on to number 2, decreasing the pressure. Now, when you increase a pressure, so I'm going to start with increasing the pressure. When you increase the pressure of such a reaction, this reaction is happening in a container. It's a closed container, and I'm going to increase the pressure. So when I increase the pressure, the reaction is going to move in the direction where there is fewer gaseous molecules. And in this case, there are fewer gaseous molecules over here, because over here, it's just 1 mole of gaseous molecules, whereas over here, it's 2. So if I increase the pressure, the reaction is going to shift to the left. So the reactants are going to be favored. So increasing pressure means that the reactants is going to be favored, or the left-hand side is going to be favored. Decreasing pressure would mean that the right-hand side is going to be favored. So it's just going to be the opposite for decreasing pressure. So if I decrease pressure, it's going to favor, or it's going to shift the position of equilibrium to the right. Whereas if I increase the pressure, it's going to shift the position of the equilibrium to the left. And that's why decreasing pressure does indeed shift the position of the equilibrium to the right. Therefore, 2 is also correct. And that would mean we can eliminate B because 2 is not even an option there. And out of A and D, we already discussed earlier that the catalyst actually has no effect on the position of the equilibrium. Therefore, D is automatically wrong and A is our correct answer. So now there I've showed you 2 methods of approaching this question, one which requires a bit more reasoning and better understanding of the topic, and the second one which is slightly longer, but of course, it also requires you to have a very good understanding of all the different factors which affect the position of the equilibrium and how they affect the position of the equilibrium. Now, if you don't know a lot about this or you're still very confused, please let me know down in the comments below and I'll do a more detailed video about this. Or if you have any other questions regarding any other concepts, please message me on my social media, send me an email, or put it down in the comments below, and I'll be more than happy to help you. And hopefully you have found this video helpful. I will see you in another video with another question. Thank you so much for watching.